we are going to do today is learn how to graph the sine and the cosine functions. And I will expect you to know what these basic graphs look like and to be able to graph them without the aid of your calculator. So we're going to look at some ways that we can easily graph. First of all, we want to graph the sine function. So we're going to look at y equals the sine of x. Now I have a unit circle here, and you may have one at your desk or in your book that you want to look at. But remember when we first looked at the unit circle, we added a third variable, a t, and we said that the t was what wrapped around the unit circle, all the way around, and it had a real number associated with every point on that number line. Well, we're going to kind of unwrap the unit circle. And I'm going to, let me move this up just a little bit. I'm going to start by drawing an x and a y axis. Here's our x, and here's our y. All right, now let's think about this. If I unwrap the unit circle, we start here with 0, and then here we've got a pi over 2, and then we're going to have pi, and then we'll have 3 pi over 2, and 2 pi. I'm just hitting those quadrantal angles. And we're going to look and see if we were to graph the sine and the cosine through one period, through one complete rotation around around the unit circle, what that graph would look like, what those values would look like. Now, what did we say that the range of the sine was? What's the lowest value the sine could be? -1. And the highest value it could be right here? 1. Okay, so we said that the range for the sine function is -1 to 1. Do you remember what the domain was? All real numbers. All right, the domain for the sine function is all real numbers, and the range is -1 to 1. When we say the domain's all real numbers, that means we're not going to have any breaks in our graph. We will have a continuous graph because the domain includes all real numbers. We're just using our real numbers a little bit differently than what we have before when we've used the xy axis. And most of the time, I'm going to let you draw your xy axis, and as we go through, you'll see why, and you'll be thankful that I'm letting you draw it instead of giving you a preset one, right? So first of all, the sine of 0 is what? It's 0. If you think about the point for 0, it's associated with the point 1, 0. And so the sine is the y value, so the sine is 0. What's the sine of 1/2? What's the sine of 1/2? 1. Is it not showing up there? I'm graphing the points.
Yes.
Okay. I probably was pointing to it. Sorry. The pointer won't show. The sine of pi. 0. And we could be doing all these points in between, but we're just for brevity, we're looking at the x-intercepts and the maximums and the minimums. All right. What is the sine of 3 pi over 2? -1. And the sine of 2 pi? 0. All right. I have gone around the unit circle one time. I have completed one period of the function. And now what we're going to do is just connect those dots. And let me see if I can find, let's do it in red. Okay, I'm going to connect those dots, and it's going to look like this. That is 1 period of y equals the sine of x. If I were to erase, let me see, oh, it's too late to erase that. It's not going to let me do that. Okay. We could keep going. If I extend this out, and it's harder to do on this, but the reason I'm doing it on the iPad is so maybe it'll help those that are not here today. We could extend this out and this pattern would repeat. We'd have 2 pi, and then the next was, this is 4 pi over 2, 5 pi over 2, 3 pi, and it would keep on going, but it's going to look, we're going to have another maximum here. And it would keep going like this. If we backed it up this way, this would be negative pi over 2 and negative pi. And that would be, actually that is 2 complete periods of the function, even though if you think about starting at pi, if we started here, the period would end here and at pi, and then at 3 pi. Notice between pi and 3 pi is 2 pi. So I have really graphed 2 periods of this function. Normally we will start it at 0. Okay, now we want to look at the graph for y equals the cosine of x. And I'm going to graph my y and my x-axis. And we'll do the same thing that we did before. I'm going to graph those quadrantal angles, which are pi over 2, pi, 3 pi over 2, and 2 pi. And let's just graph 1 period of the sine function. Let me see if I can change my color. I don't know why this is so hard to get the colors up sometimes. All right, so what if this is 1 and negative 1? Just like the sine function, the range for the cosine is from negative 1 to 1, and the domain is all real numbers. So those are important things to remember. Now, what is the cosine of 0? Yes. The cosine of 0 is 0. Unit circle. Remember, you've got if you can't see my unit circle, we're only looking at quadrantal angles. And if we're thinking about quadrantal angles, you've got the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Really, all I'm asking you to do for these graphs is the quadrantal angles. All right, so the cosine of 0 is 1.
Wait, okay.
What is the cosine of pi over 2? Why is it so what? You want me to change the color?
Yes, please. The green is pretty. No, I can't see it.
Okay, what's the cosine of pi over 2?
0.
0. What's the is the blue easier to see? What's the cosine of pi?
Negative 1.
The cosine of 3 pi over 2.
0.
And the cosine of 2 pi. Okay, once you get back to where you started at, we started at 1 and we end at 1, that's 1 period. And if we connect the dots, there is 1 period of y equals the cosine of x. Now, if I continue another period, we've got 2 pi. This is 3 pi over 2. The next one's going to be 5 pi over 2. 3 pi, 7 pi over 2, and 4 pi. Okay, so 5 pi over 2, we're starting around on the unit circle again. What's the value of the cosine for 5 pi over 2? 3 pi, negative 1, 7 pi over 2, and 4 pi. And so if we finish here, that is 2 periods of y equals the cosine of x. Notice the cosine starts at its maximum and ends at its maximum. Halfway in the middle of the period, it's at its minimum. And then at the halfway between those points, we're at 0. So those would be the 4 points I'd be looking for in a graph of one period of the cosine. The end points, you would need to have 4 points for each period. The maximums, the minimum, and the x-intercepts. All right, we just looked on our calculators at what happened if we put a number in front of the sine of x. And we saw that if that number was greater than 1, it stretched the graph. If it was between 0 and 1, it would shrink the graph. The same thing happens for the cosine. This fits the pattern y equals a times the sine of x, or y equals a times the cosine of x. We say that the absolute value of a is the amplitude. Amplitude is always positive. If you're asked for amplitude, it's always positive. So if we wanted to graph, we looked at y equals 2 sine of x on our calculator. Let's look at y equals 3 cosine of x and see if we can graph that ourselves. First of all, what is the amplitude? The amplitude is 3. And I don't care if you use abbreviations, but if you're asked for the amplitude, remember amplitude is always positive. Even if it looks like A is not positive, we take the absolute value of A. All right, so if we're wanting y equals 3 times the cosine of x.
Will the amplitude be kind of like the range?
Yes, it changes the range. All right, so whereas when we had y equals cosine of x, the range was negative 1 to 1, what do you think it's going to be for 3 cosine x? Negative 3 to 3. Good. So we're going to have, now, we said our period here is 2 pi. So I'm going to graph, you're usually going to be asked to graph 2 periods. So let's extend this out a little bit. So we have pi, 2 pi, 3 pi, 4 pi. Now that's 2 periods worth. We also have these marks in halfway in between. Pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. Now cosine starts at its maximum. So it's going to start here. It's going to end at its maximum. And halfway in the middle, it's at its minimum. So at these points, it's crossing the x-axis. Same thing on the second part of that, on the second period. It starts at the maximum and ends at the maximum. At the midpoint, it's at its minimum. And then halfway in between each of those, it crosses the x-axis. So if we graph y equals 3 cosine x, we go through all these points. Notice the curves are rounded. You don't have a point. It's not sharp at the maximum or sharp at the minimum. It's rounded. And that makes a difference, especially next year when we get to calculus and we begin to talk about derivatives. It's different if you have a rounded curve or a sharp point. So these are not sharp points. They are rounded curves. Think about what would happen. Let me move this up just a little bit. If we did y equals a negative 3 cosine of x. How is that going to affect the graph, that negative? It reflects it where? Across the x-axis. What's the amplitude?
3.
The amplitude is still 3, but now we have a reflection. And let me see if I can get even another color here. Let's do green. We'll try green. I know that doesn't show up real good, but maybe it'll help. Okay, so this time instead of starting at the maximum, we're going to start at the minimum. And so this function is going to have a minimum here. At pi, it's going to be at its maximum. At 2 pi, the minimum. At 3 pi, the maximum. And at 4 pi, the minimum. Is that going to affect where it crosses the x-axis at all?
No.
Not at all. So this just looks like this. Now, is the cosine function an even function or an odd function?
Even.
It's an even function. And if we look at the cosine function, an even function is symmetrical with respect to what?
No. Why?
The y-axis. If we were to continue this, well, continue the one that was in blue. I didn't change my color. Notice you have symmetry to the y-axis. What about for the sine function? Where's your symmetry? If you go back and look at your sine curve, where's your symmetry? It's not the y-axis. The sine curve looks like this. So where's your symmetry? To the origin. Your sine is an odd function which is symmetrical with respect to the origin. Notice here it looks like this. And you could probably see that better if you type it in your calculator, that you have symmetry with respect to the origin. Y equals a times the sine of bx. Now we've got a number in front of the x, or y equals a times the cosine of bx. The absolute value of a is still the amplitude, but now we've changed our period. And for the sine and the cosine, the period is 2 pi over b. Now this is why you're going to appreciate the fact that I let you draw your own x and y axis instead of having to use a preset one. All right, so if we have the function y equals the sine of x over 2, what is b in this case?
2.
It's not 2.
At 1.
It's 1/2. Okay, b is 1/2. So our period is 2 pi over 1/2, which is,
Pi.
pardon?
No, 4 pi.
4 pi. All right, so if I'm going to graph one period of y equals the sine of x over 2, the halfway point is 2 pi. It ends at 4 pi. And then if I were to carry it on out, the next period, the halfway would be 6 pi, and it would end at 8 pi. Now with the sine function, those are my x-intercepts, the beginning, the middle, and the end of each period. Halfway in between the x-intercept is pi here, and that's going to be where my maximum is. This is 3 pi, 5 pi, and 7 pi. The amplitude here is 1. So we start here. We cross at 2 pi, we cross at 4 pi, we cross at 6 pi, and we cross at 8 pi. We're at our maximum at pi and minimum at 3 pi, maximum and minimum. And so there's the graph of y equals the sine of x over 2.